All right, this video is for the dividing radicals, rationalizing the denominator scavenger hunt. So what you have is you've got this recording sheet. This is all you got to turn in at the end. You've got this packet that's got celebrities, and then it's got their dogs. So the celebrity is the original, the dog is the simplified version. And it's matching, so once you use it, it's gone, it's out. And it kind of helps you eliminate answers as you go. Okay, so we are going to start, let me grab my list here. We are going to start with number 4. We're going to look at Adele. All right, so this is what we did yesterday. So just a quick little review. Square root of 4 over 4 times the square root of 5. Now, I can multiply by this whole piece. But all I have to multiply by is the square root of 5 in this case. Okay? So, multiplying two radicals, keep the radical, multiply the numbers underneath. 4 times 5 is 20. Here, 4 times the square root of 5 times the square root of 5. Mathematically, what happens? You're going to do 4 times 5. You do 20. Okay? Now, square root of 20. Will that break down any further? 20 is 2 times 10. 10 is 2 times 5. Remember, all we need is a pair, and it breaks down. So 20 is the same as the square root of 2 squared times the square root of 5. This cancels this. So square root of 20 is the same as 2 times the square root of 5 over 20. But I'm still not done. Is there a common factor between 2 and 20? Yeah, 20 is the same as 2 times 10. I can break it apart into factors. So if I have the same number on the top and the bottom, they cancel. So my final answer is the square root of 5 over 10. Okay, so we got to find the dog that has the square root of 5 over 10. Oh, there it is. Louis. So once you use it, it's done. You're not going to use it again. And then next to Adele, you just write Louis. All right, we're going to jump down here to Kelly Osbourne. We're going to jump to number 9. And you can pop the staple in this if you need to. You do whatever you need to. Just keep your pages together. All right, here we go. Here's the new for today. So we're no longer just dividing by a monomial. A monomial is one term. Now we're dividing by a binomial. So we can't just multiply by the square root of 3, because then that would leave us with, 3 times the square root of 3. So anytime your denominator has an addition or subtraction, again, it's a binomial, you multiply by what's called the conjugate. Okay? Scary word, easy concept. All you do is you take this binomial, and if it's a plus sign in the middle, you change it to a subtraction sign. So if it's a subtraction, you change it to an addition sign. That is called multiplying by the conjugate. I always do the bottom first. I always do the bottom first to make sure that I'm canceling what I need to cancel. So how we multiply binomials is using the FOIL method. Okay? F is for first. The first number in each set of parentheses. So 3 times 3 is 9. Outside. The outside terms of each set of parentheses, which would be the 3 and the -4 times the square root of 3. Here we just multiply the coefficients. 3 times negative 4 is a negative 12, and we just tack that square root onto the end. Inside are the inside terms, the terms that are on the inside of those parentheses. So 4 times the square root of 3 times 3. 4 times 3 is 12. Tack on the square root of 3. Last are the last terms. So we've got 4. So to show you mathematically what's going to happen here, 4 times the square root of 3 times negative 4 times the square root of 3. Mathematically, what happens here? We're going to multiply this 4 times this 4 times negative 4. And then when we multiply a square root of 3 times a square root of 3, that simplifies just down to another 3. Okay? So you could do it a piece at a time and go, okay, 4 times negative 4 is negative 16. And then square root of 3 times square root of 3 is a 3. Can you see the pattern? 4 times negative 4 is 16. And then negative 16 times 3 is a what? Negative 16 times 3 is a negative 48. So what we're wanting to happen is this right here. Negative 12 times the square root of 3, positive 12. We want everything to be the same except for the sign. If these are opposites, they cancel each other. And so now, on the bottom, all I'm left with is 9 times a negative 48. So I've got a negative, or not times, minus. I am so sorry. 9 minus 48. They're terms. I apologize. 9 minus 48. So I've got a negative 39 on the bottom. To do the top, we just distribute this 2 to each term. Distribute as multiply. 2 times 3 is 6. 2 times negative 4 is a negative 8. Tack the square root on. There's no like terms. There's no common factor between 6 and 8 and 39. But we don't like negatives on the bottom. So to get rid of the negative on the bottom, we multiply by a negative 1 is what you're doing. All you're doing is you're flipping everybody's sign. If you're flipping everybody's sign, you're staying equivalent. So positive 6 becomes negative 6. Negative 8 becomes positive 8. Keep that square root. Negative 39 becomes positive 39. We are going to do several more, so don't panic yet. All right, so we're looking for a bottom of 39. The bottoms, there's not many that repeat, so you can check using just the bottoms. So that's Noodles. So Kelly Osborne is Noodles. So on a lot of these, if they don't need further simplification, if you can just get the denominator, you can kind of go through and check and find the right answers. Not all of them, but some. All right, we're going to do number 10. We're going to do Jim Carrey now. Okay. So we've got 4 over square root of 2 minus the square root of 5. So again, anytime there's that addition or subtraction, we're going to multiply by the conjugate, flip the sign in the middle, and whatever you do to the bottom, you have to do to the top. So on the bottom, we've got to use FOIL. Is everybody seeing when I'm saying what the first is, what the outside is, what the inside is, what the last is? Does that make sense? You should have done FOIL before with quadratics. All right, square root of 2 times the square root of 2 is just a 2. Outside, square root of 2 times the square root of 5. Keep the radical, multiply what's underneath. 2 times 5 is a 10. Negative square root of 5 and then positive square root gives me a negative square root. The number underneath does not change. The number underneath is still 5 times 2. The negative goes out in front of that thing. So same here. Negative square root of 5 times the square root of 5. The radicals cancel and I'm left with the 5, but I still have that negative sign. So just be really careful with signs. So positive square root of 10 and negative square root of 10 cancel. 2 minus 5 is a negative 3. And then here on the top, we just distribute. If we're just distributing a solid number, we're just tacking that number in front of those radicals. No common factor again between 4 and 3, but we don't want that negative at the bottom. So we just change everybody's sign. Okay, so we're looking for a 3 on the bottom. George? Does that one match? So Jim Carrey, you're going to write George. Okay, we're doing okay so far. Let's skip to Miranda Kerr. Let's go to number 12. Do y'all know who Miranda Kerr is? Sex and the City, the redhead? Okay, we are going to ignore this negative. We're going to leave it there. We're not going to mess with it yet. So we've got 5 times the square root of 2 over 3 minus the square root of 2. So minus in the middle becomes a plus in the middle. Whatever we do to the bottom, we have to do to the top. So, FOIL. 3 times 3 is 9. 3 times the square root of 2 is 3 square root of 2. Negative square root of 2, remember, there's like an invisible 1 there. So really, when we're doing the inside here, we're doing negative 1 times 3 gives me a negative 3. And then just tack in that. So just, again, just be really careful with those negatives. Don't drop a negative. And then, negative square root of 2 times positive square root of 2 gives me a negative 2. So these cancel. 9 minus 2 is a 7. All right, and then we're going to distribute this monomial. So 5 times 3 is 15. Tack on the square root of 2. 5 square root of 2 times square root of 2. We do, what happens there? 5 times the square root of 2 times the square root of 2. What happens? What happens when I multiply those? I take out the square root and I just keep one of the 2's, right? So it turns into 5 times 2. So just 10. All right, and then we've got this negative to deal with, right? That negative is still out in the front. We apply it to everything on the top. So positive 15 becomes negative 15. Positive 10 becomes negative 10. And again, we like the bottom, we like the denominator to be positive. All right, so we're looking for a bottom of 7. Frankie. So that's Miranda Kerr. All right, so to make sure that I get the hardest ones done, we're going to go ahead and jump all the way down to the bottom. Okay? Again, there's a few more that I want to work with you, but I want to get kind of through all the different levels of this. So let's look at number 20. 20 is about as complex as these get. So again, it doesn't matter what's on top. It's the bottom. I want to multiply by the conjugate. Okay. So we're going to FOIL the bottom. 3 times 3 is 9. Outside. 3 times negative 2 is a negative 6. Tack on the square root. Inside, 3 times 2 is a positive 6. Tack on the square root. And then 2, we would do 2 times negative 2 times 6. Okay, and again, if you do that piece in your calculator, if the radical is the same, you can do it in your calculator. I can't make it where you can see everything, but 2 times the square root of 6 times negative 2 times the square root of 6 is the same as 2 times negative 2 times 6. Okay? And it's your eyes will start to see it a little bit better. If you need to write down the steps, write down the steps. All right, so this and this cancel. And then we're left with 9 minus 24. 9 minus 24. So my bottom is a negative 15. I have to FOIL the top this time too, because they're both binomials. Okay, so I got to FOIL again. So first, 6 times 3 is 18. Tack on the square root of 2. Outside, 6 times a negative 2 is a negative 12. And then underneath, since it's different, 2 times 6 is a positive 12. Inside, 3 times 5 is a 15. Tack on the square root of 5. And then last, 5 times a negative 2 is a negative 10. 5 times 6 is a 30. But I'm still not done, because some of these will break down. Will the square root of 2 break down? No. So we know that one's going to stick. So I'm going to start another page here. Sorry, I just write really big. So we know we're going to have 18 times the square root of 2. What about the square root of 12? Will that one break down? 12 is 3 times 4, 2 times 2. So this 2 will pull out. 2 times a negative 12 is a negative 24, and all I'm left with is that 3. Square root of 5, that one won't break down. What about 30? 5 times 6, 6 is 2 times 3. That one won't break down either, will it? 10 square root of 30. All of that is still over that original negative 15. Then we look, are there any common factors between 18, 24, 15, negative 10, negative 15? And you kind of go through the basics. Will a 2 divide evenly into all those numbers? Will a 3, 4, 5? And usually once you get to that point, you're kind of like, yeah, there's not anything that's going to go in there. Last step, flip the signs. So negative 18 square root of 2. Positive 24 square root of 3, negative 15 square root of 5, positive 10 square root of 30, over positive 15. Again, that's about as complicated as they get. Over a 15, let's see. Oop, it's Mimi. So again, typically if you can look and kind of match up the bottom number, that gives you a starting place. So 20 is Mimi LaRue. Last one I think we're going to have time for. I'm hoping I can get through it. Let's see. I can get through it. Let's jump back up to number 17. All right, here we go. 17 has a lot of simplification. So that's Christina Ricci. So negative 3 minus 3 times the square root of 3 over 3 minus 5 times the square root of 3. I'm going to multiply by the conjugate. 3 plus 5 times the square root of 3. 3 plus 5 times the square root of 3. All right, I'm going to FOIL the bottom first. 3 times 3 is 9. Outside, 3 times 5 is 15. Tack on the square root of 3. Inside, negative 5 times 3 is negative 15. Tack on the square root. And then here, negative 5 times positive 5 is a negative 25. Times the 3 is a negative 75. This cancels this. 9 minus 75 is a negative 66. There's where my bottom starts. Then I got to FOIL the top. Negative 3 times positive 3 is a negative 9. Outside, negative 3 times 5 is a negative 15. Tack on that square root. Inside, negative 3 times positive 3 is a negative 9. Tack on the square root. And then last, negative 3 times positive 5 is a negative 15. Times this 3 would be what? Negative 45? 3, 5, 15, yeah, 45. Okay. Notice how they didn't cancel out this time. Okay, but here's what they do have. These are like terms. So just like if this had been an x instead of a square root of 3, I can keep the square root of 3 and then negative 15 plus a negative 9. I can combine the coefficients. Negative 24. This is the only time that you can add or subtract radicals, is if the number underneath that square root is the same. You can add the numbers that are in the front or subtract the numbers in the front. It's the only way you can add or subtract radicals. Okay? And then I can combine these two. Negative 9 plus negative 45 is negative 54. So that's what I have on top. Negative 54 minus 24 times the square root of 3. I can still simplify. Even higher than that. 6. 54. So here's what I'm going to do. I'm going to pull the negative out. Okay. 54 is 6 times 9. Pull this negative out. 24 is 6 times 4. Keep the square root of 3. Negative, and then 66 is 6 times 11. So to be able to cancel that 6 out, in each term I have to have a 6 as well. So those two will cancel out with that single 6 on the bottom. So now what I'm left with, negative 9 minus 4 square root of 3, and then negative 11. Final step is to get rid of the negative on the bottom. So everybody on the top flips. Negative 9 becomes positive 9. Minus 4 becomes plus 4 square root of 3. Negative 11 becomes positive 11. And I believe that is sheriff. That is the last one we are working today. Hang on to this. I will work another 4 with you tomorrow.